problem is to count the number of distinct islands in a 2D grid, where 1 represents land and 0 represents water. An island is a group of land cells connected horizontally or vertically, surrounded by water. In our case, we're working with a 5x5 grid. We'll animate the logic of DFS as we explore the grid, one cell, one island at a time. Here's the pseudocode we'll be walking through. The algorithm scans each cell in the grid, and when it finds an unvisited land cell, it uses DFS to mark all connected land cells as visited, counting each group as one island. Let's dive in. We start by scanning the grid row by row, column by column, looking for unvisited land cells marked as 1. For each cell, we check if it's a land cell and hasn't been visited yet. If it is, we've found the start of a new island. When we find an unvisited land cell, we increment our island count and kick off a DFS from that cell to explore the entire island. In the DFS phase, we focus on the current cell. First, we check if it's valid, within the grid bounds, a land cell, and not yet visited. If the cell is invalid, maybe it's out of bounds, a water cell, 0, or already visited, we exit the DFS for that cell and backtrack. If the cell is valid, we mark it as visited. In our visualizer, the cell turns yellow and shows a check mark to indicate it's part of the current island. Next, we recursively explore the 4 adjacent cells, up, down, left, and right, to find any connected land cells. For each adjacent cell, we repeat the DFS process. Check if it's valid, mark it as visited if it is, and continue exploring its neighbors. This recursive exploration continues, spreading out to all connected land cells, ensuring the entire island is marked as visited. What happens when we hit a dead end, like a water cell or a visited cell? The DFS stops for that path, and we backtrack to the previous cell to try another direction. Each time a DFS call completes, we pop it off the stack, closing the corresponding pop-up window in our visualizer. Once we've explored all connected land cells for an island, we return to the main loop and continue scanning the grid for the next unvisited land cell. This process repeats until we've checked every cell in the grid, counting each new island we find. When we're done, the total number of islands is displayed, and all land cells in each island are marked as visited. Let's recap how DFS worked here. Scan the grid for unvisited land cells. For each unvisited land cell, increment the island count and start a DFS. In DFS, mark the current cell as visited and explore its neighbors recursively. Backtrack when hitting invalid cells, ensuring all connected land cells are visited. Continue until the entire grid is processed. This logic is reflected in the code. As the algorithm runs, each step highlights the corresponding pseudocode line, showing exactly what's happening. The number of islands problem is a fantastic example of how DFS and recursion can explore connected components in a grid. By visualizing each cell check and recursive call, we gain a clear, intuitive understanding of how the algorithm works. Try clicking through the steps yourself, watch the grid update, and see how islands are discovered and marked. Thanks for exploring with us. If you found this explainer helpful, don't forget to like, share, and subscribe for more algorithm animations.